All right, time for some algebra. We're going to be learning how to solve systems of equations using the algebraic method of substitution. There is another algebraic method we'll look at in the next lesson called elimination, but in this case, substitution, something we're somewhat familiar with. So the reason why we use algebra, again, I've mentioned this before, is that graphing is sometimes inaccurate. You don't always have nice even numbers. Sometimes we're using fractions and decimals that might lead us to not intersecting on nice even grid lines, and so we can't tell the exact point of intersection, and we can only approximate it unless we're using something like technology, computer, or a graphing calculator. That'll be able to give us a more accurate value. And sometimes this graphing is inconvenient, so we use the algebraic methods to solve these. So you've done something like this before when solving equations. When you've made a t-chart, you've done a form of substitution, or whenever you've worked with an equation, you've done a form of substitution. We're just going to expand upon that. So here, we're going to start with the equation 1, y equals 4, and equation 2, here, y equals 3x minus 2. Always number your equations, okay? Number them 1 and 2, because we're going to give directions as to what we're actually doing at each step. And you're going to write these out every single time in just little short forms, but it keeps the person looking at your work to understanding what's going on, and it'll help you understand as you build your skills here. So we want to recognize that y equals 4, and when these intersect, the x and y values will be the same. So we're going to take y equals 4 and notice that y is equal to y. So I can take y equals 4 and I'm going to sub it in here. Just like if I said solve this equation when y equals 4, we've done questions like that. This is what we're doing here, y equals 4. So I'm just going to replace the y here with the 4. So we're going to sub equation 1 into equation 2. That's my little statement. So we'll put that in there. 4 equals 3x minus 2. And now I just need to solve this for x. I'll move the 2 over. 4 plus 2 equals 3x. 6 equals 3x. And then divide both sides by 3. 2 equals x. So there's my x value. I already know that the y value is 4 from the original statement. So here's my point of intersection. X is going to be 2 and y is going to be 4. I can check that if it works by subbing this value back into here and seeing that 3 times 2 is 6 minus 2 is 4. That's the same as the y value. That works out. So here, therefore, the POI, and always make a little statement, 2 and 4. Okay? Just so that I can easily find your answer. In the next one, instead of y equals 4, we have x equals a number, so in this case x equals 6. Working with the same second equation though, so 1 and 2. So we're going to do the same type of procedure. We're going to replace the x with 6. So we have sub 1 into 2 again. So we're going to sub equation 1 into equation 2. And we're going to get y equals 3 times 6 minus 2. I don't need that extra bracket there at the end. Y equals 3 times 6 minus 2. Calculate that. 3 times 6 is going to give me 18. 18 minus 2 is going to be 16. So there I have my x value and my y value for the point of intersection. Therefore, POI is 6 and 16. And that's where those lines would intersect. Now, let's amp it up. Here we've been subbing in a number. Now we're going to sub in a letter. Here I have y equals x. So y equals x. X is just a variable, meaning it's some number. We don't know what number yet. So just like up here where I had said y equals 4 and I replaced the y with the 4, I'm going to do the same thing here. I'm going to substitute this x in for this y. So I get sub equation 1 into equation 2. And I'm going to have x equals 3x minus 2. Rearranging this, I'm going to take the 3x and subtract it from both sides. I'm going to be left with negative 2x equals negative 2. And finally, when I divide both sides by negative 2, I'm left with x equals 1. So that is my x value. However, unlike the last few questions where we already had the other value, I don't have the second part of this point. So now I have to sub this value, x equals 1, into one of these equations. It does not matter which one, they will both give me the same answer. So I'm going to pick the easy one and sub it into equation 1. So now I'm going to sub x equals 1 into equation 1. And I'm going to get y equals 1. That's it. That's all. X and y equal 1. Therefore, the point of intersection is 1, 1. So here, just like the 6 and the 4 in the previous questions, I just substituted that value of x in for the y. I could have also substituted y in for the x and solved it that way. Both would have given me the same answer. I would have got a y equals 1 first and then got the x equals 1. Let's try to amp this up now. So here I have two equations. Got equation 1 and equation 2 where I have a full piece here. Negative 2x plus 3 equals y, and then the 3x minus 2 equals y again. I'm going to follow the same procedure. Every time I was taking this part here and subbing it in for y, I'm going to do that again. So I'm going to replace this y with negative 2x plus 3. So I'm going to sub 1 into 2, and I'm going to get negative 2x plus 3 equals 3x minus 2. I'll just rearrange this to solve it. I'm going to move subtract 3x from both sides, negative 2x minus 3x, and I'm going to subtract 3 from both sides, negative 2 minus 3. I'm going to get negative 5x equals negative 5. Divide both sides by 5, and I'm left with x equals 1. There's my x value. Now I have to find my y value. Again, it doesn't matter which equation I choose to use, equation 1 or equation 2. They will both have the same answer because this is the point where they intersect and the x and y value is the same. I'm going to use equation 2. So I'm going to sub x equals 1 into 2. And again, I want you putting these statements down to show what you're doing along the way. Helps keeps things organized. Y equals 3 times 1 minus 2. Now I calculate that. 3 times 1 is 3 minus 2 is 1. So in this case here, they intersect at 1 and 1. Therefore, the point of intersection is 1, 1. Do note, it's not always going to be like that. It just happened that both of these equations had the same point of intersection. I made up a random equation here. It just worked out. If we move on to the next one here, we see there's a little bit of difficulty because all the previous equations were y equals. They were already in y equals format. Now we have to rearrange at least one of the equations so that it is x equals or y equals. Does not matter which equation. We're going to select the one that we think is easiest. You might think a different one's easier than me. I always try and pick the one I feel is going to be easiest to rearrange. Again, it doesn't matter which one you choose. So I'm going to label them 1 and 2. I think I'm going to rearrange equation number 2 here, and I'm going to move that 2x over to the other side. So I'm going to rearrange 2. So I'm going to state I'm rearranging equation 2, and I'm going to get y equals 3 minus 2x. When I do that, so if I added subtracted 2x from both sides, and now I have an equation here. This is still equation 2, just rearranged, that can fit into here and replace the y value. I can replace the y value with 3 minus 2x. So let's do that. Sub 2 into 1, and I'm going to get 5x equals, replace the y. I'm going to put it in brackets because there's more things on that side just in case there was a multiplication or something there. I'm going to make sure I use my brackets around that. Plus 11. If this was something like 4y, I'd have to multiply and expand that bracket first. In this case, I don't have to. So those brackets become unnecessary in this specific case. I'm going to get rid of them now. I'm going to collect my like terms, and I'm going to also add add 2 to both sides, 2x. 5x plus 2x equals 3 and 11 is going to add up to 14. 5 plus 2 is 7x equals 14. Divide both sides by 7. Left with x equals 2. So there is the rearrangement and solving for x. And again, we're not done. We've only found the x value. We also need to find the y value. I'm going to go back and use this equation here. It's already y equals, so I'm just going to sub in the x value here, and that should help me out in finding the y. Sub x equals 2 into equation 2. I'm going to get y equals 3 minus 2 times 2. And 2 times 2 is 4. 3 minus 4 is going to give me negative 1. There's my y value of negative 1. Therefore, the point of intersection is 2 and negative 1. A few more examples of situations that can occur as we do these. In the next case here, I have y equals 1/2 x minus 5, and 10 equals x minus 2y. So the first equation is already in y equals form, so I can just go ahead and sub that right into the second equation. So let's do that. Sub 1 into 2. So I'm going to get 10 equals x minus 2 times, and so I'm putting my brackets in because I'm subbing this whole thing in. It needs to be multiplied by 2. 1/2 x minus 5. As I expand this out, I'm going to multiply each term in the brackets by the negative 2. 1/2 times negative 2 is going to be negative 1x, so negative x. And then the negative 2 times the negative 5 is going to give me plus 10. X plus x, when I collect those like terms, get rid of each other, and I'm left with 10 equals 10. And so when I get the case of this, where I have the same, no more variables, and a number equals itself, what I have, when you get this case, and it won't be very frequently, that you'll run into these with our situations, but in some cases you will. If the number equals itself, then what you have is infinite solutions, as they are the same line. These are both the same line, and thus we get infinite solutions. If you rearrange equation 2, you will find that what you get is y equals 1/2 x minus 5. So you get the same equation. In the next case, again, I already set up the second equation to be y equals, so I can just directly sub in x equals 2 into the first equation. sub equation 2 into equation 1. And so I'm going to be left with x minus bracket x plus 2 equals 4. If I expand that bracket out, we're multiplying by negative 1, so I'm left with negative x and a negative 2 equals 4. X minus x goes to 0, so I'm left with negative 2 equals 4. In this case here, this is not true. There's never a case where negative 2 equals negative 4. That means these lines do not intersect. No solutions. These are parallel lines. So we have parallel lines. If you have two different numbers on either side of the equal sign, we have the same line if we have the same number on either side of the equal sign. Finally, we're going to try this out with a word problem. So we're going to have to, the only difference in the word problem is we have to create our equations first. So here we have Ron making two types of sweaters. To make the first, he charges $35 for the material and $60 an hour for labor. For the second, he charges $105 for the material and then only $25 an hour for labor. At what number of hours are the costs the same? So we're going to find out the same cost in hours. That's going to be our point of intersection. So I'm going to create two equations. The first equation, the cost equals $35 plus $60 an hour. So that'll be equation 1. The second equation will be cost equals $105 plus $25 an hour. So now I got two equations. I can solve them simply by subbing one of them into the other. They're both C equals, so I can just set them equal to the other half equal to each other. Let's say sub 1 into 2. So I'm going to have 35 plus 60h equals 105 plus 25h. And I'll do some rearranging. I'll move all my h's to this side, so 60h minus 25h equals 105, and then I'm going to subtract the 30 on the other side, 35. So I have 60 minus 25, so that's going to give me 35h. 105 minus 35 is going to give me 70. Divide both sides by 35, and I'm left with h equals 2. What number of hours are the costs the same? After 2 hours. I don't have to find the cost in this case because the question only asks for after how many hours the cost would be the same. So we're not worried about the actual cost itself. If it asks for the cost as well, then we have to calculate that. Well, therefore, costs are equal at 2 hours. Something like that. So there we have solving systems of equations. Make sure you're numbering your equations and stating each step what you're subbing into what in order to make it easier to follow. Try and, again, keep it organized, and you should have, you find this would be pretty easy.